Hi, this is Merge Intervals in a Few Minutes by Study to Simple. So this is an algorithm that you can use for any problem that asks you to merge intervals or find X number of overlaps, anything like that. So real quick, to understand the problem, we want to go from an input of something like this to an output of something like this. So the interval that we merged is 1, 3, and 2, 6. So we decided that there was a merge here, and we merged them into 1, 6. So our answer is 1, 6, 8, 10, 11, 12. And real quick, some side notes we need to note for this problem are that when an end time and start time are equal, that will be considered a merge. Also, our input list of meetings is already sorted by start time. So you can see 1, 2, 8, 11. They're in ascending order, right? So if we kind of think about the types of overlaps there can be, we should come up with 4 possibilities, which are shown here. So basically there's some where there's half of an overlap, and there's some when one totally encompasses the other. But how can we actually computationally detect these overlaps? We need some kind of condition, right? So what should that condition be? Well, we know that our list is sorted, so S2 will never be less than S1. So that automatically rules out these 2 types of overlaps, just by virtue of the list being sorted. And that leaves 1 and 4 as the types of overlaps that we need to be worried about. And what can we see in common here? Well, we can see that S2 starts before N1, which means the second meeting starts before the first meeting ends, the definition of an overlap. And we can see that that condition actually holds for this example too. S2 starts before N1, which means this meeting starts before this meeting ends. So now we can come up with this condition to detect overlaps. But before we can get into a live run, there's one last thing we need to be worried about. Overlaps can involve more than 2 intervals, right? There's nothing that says there's only going to be 2 intervals at a time that have an overlap. The problem actually says merge all intervals with an overlap. So that could involve more than 2, right? So that's an example we also have to be prepared for. So an example like this, cascaded overlaps should result in 1 merged interval. Okay, so the last thing we need to determine is how to actually merge intervals. So if 1 and 3 and 2 and 4 had a merge, how would we actually merge them? Well, it's clear to us that we would want these to turn into 1 and 4. Right, we want the merged interval to fully encompass both subintervals. And we do that by choosing the smallest start time and the largest end time. Okay, so let's go ahead and run through this. So we initialize 2 sets of pointers, and we find that there's an overlap here. And we know that through our condition that we just determined. So 2, S2, is less than or equal to E1, 3. And so we're going to have to merge these 2 intervals. So S1, E1 now reflects the merged interval. And now we iterate forward because we need to check the rest of the intervals. And we do the same thing. Again, we detect another overlap. Remember, we're going to consider equivalent elements, equivalent start and end times to be considered an overlap. And so we do our merge again, choosing the smallest start and the largest end. And so this is our merged interval now. And then we iterate forward. And again, we hit our overlap condition again. And so we merge them again, choosing the smallest start time and the largest end time. So in this case, our answer, as can be seen, would be 1 and 7. This is our merged interval, and you can see that all 4 of these subintervals actually fit inside here. And here's the exact code for those who are interested.